The following is the video solution from JSDT Solutions. Question 9 says, a farmer has a piece of land in the shape of a right-angled triangle, and that is OMN, okay, as shown in the figure. He allocates a rectangular piece of land, PTOR, to his daughter, giving her the freedom to choose P anywhere along the boundary MN. Okay, so it means that she can decide to have this land. If P, for example, is over here, then she would have this part. Or she could have it like this if P is over there. And they tell us that let OM be A, so that's the length of OM, since the X value of M is A. And ON be B for the same reason. And P, which is X and Y, be any point on MN. And the question 9.1 says, determine an equation for MN in terms of A and B. So A and B will be included in our answer. So how do we find the equation of this line MN? Well, we have 2 points on the line. We have M, so we'll call that our X1 and our Y1. And we have N, that's X2 and Y2. So to find the equation of a line, you first need the gradient. So gradient is equal to y2 minus y1 over x2 minus x1. So this is equal to, and we're going to say y2, which is b. So that is b, this is the gradient of mn, b minus 0, okay, that's the y1, over 0 minus a. And so the gradient of mn is simply equal to, that's going to be b minus 0 is b, and 0 minus a is negative a. Okay, so we can see it's just going to be negative b over a. So the equation of this line can be in the form of y equals mx plus c. So we just need to find c. Okay, what is c? Well, they already told us what this y value is. This is the y-intercept. It's on the y-axis, intersects the y-axis. So this is our c value b. So that means the equation of this line is simply y equals negative b over a x plus b. And that is our equation. Question 9.2 says, prove that the daughter's land will have a maximum area if she chooses P at the midpoint of MN. Okay, so we have to find that maximum area of that shape, right? PTOR. We have to find the maximum area of that. And this maximum should happen at the midpoint. So in this question, we can either choose to find out where exactly does that maximum area happen, or we can find the midpoint first. And then if they match, then it means that the maximum area does happen at the midpoint. So let's look at what the midpoint is so that we know what we should get. Let's find the midpoint of that line. So the midpoint of line MN, if M is A and 0 and N is 0 and B, let's find the midpoint using the midpoint formula. Okay, so we'll find the midpoint by substituting those points in. And so this will give us that point P, well, supposed P. So we'll just say it's the midpoint of MN so long. And we have A plus 0 over 2. And this is going to be 0 plus B over 2, which just simplifies to the midpoint of MN simplifies to A over 2 and B over 2. That's really it. So we're going to find that maximum area. And if it occurs at this point, then we know that she will have the maximum area if she chooses the midpoint of MN as that point where P is going to be. So how do we find the area first? So we have to find the area before we can find the maximum area. This is the shape that we're looking at, right? We're looking at the area of the shape. So its x value, remember we just found the equation of this line, so it will help us at that point. So we know that the x value is just x. So we'll call that x. That is the length of the side. And the y value is y, but we found y equals mx plus c. So in place of y, we can substitute this as the y value. Okay, so y is that point, negative b over a x plus b. That's what we're going to do. Okay, so what that would mean is we can just write that first. Tell them that P is this point x and the y value is negative b over a x plus b. And now we can finally tell them what the length of these sides are. So OR, that is an x value. Okay, what is that value over there? And that will tell you the length of OR. So that is x. And then OT is the width. So that's the length and the width. Okay, and the width is going to be that y value because you'll go from 0 up by that y value to get that length. Okay, so let's just put down our OR and OT. OR is x, OT is negative b over a x plus b. Now naturally, to find the area of a shape, you say the length times the width, okay, or the breadth. So we're going to do that. So the area of this shape, it was PTOR, right? That shape PT is PTOR. So we'll say area of PTOR is equal to, and we'll say OR multiplied by OT. So this is equal to x multiplied by negative b over a x plus b. Okay, so this is equal to, and we can just distribute. So if we distribute, we get negative b over a x squared. You see, it's already quadratic. And then x times b, which is positive xb. I'll call it bx so that it's in terms of x. Okay, so this is the area. Let's call it a of x. Found the area. And now, how do we find the maximum area? See how this is a parabola, specifically a concave down parabola, seeing that b over a is a negative value. So to find the maximum of this parabola, this will happen at the turning point. And at the turning point, this is the place where the gradient is equal to 0. So that's what we're going to do. Find the gradient of this function and make it equal to 0. So a prime of x is what we're trying to find. And we'll say coefficient times exponent. So we're going to just say the 2 times the b. So that's negative 2b over a. And then our variable is x. And then 2 minus 1. Exponent minus 1 is 1. You don't have to rewrite that. Then here, when we are deriving, we're saying coefficient times exponent. So plus b. And then exponent minus 1. And that falls away. Okay, so this is the gradient of this function. We want to know whether the gradient specifically is equal to 0. So we'll rewrite that. And now we can finally solve for x. Okay, because right now we're just trying to find out the x value at which this will have a maximum area. Okay, so to find x, transpose the negative value. So that's positive 2b over a. X is equal to b. And then to get rid of this coefficient to solve for x, you can decide to divide both hand sides, but that can be because you still have to sort it out here. It's variables, it's not numbers. So just multiply both hand sides by a over 2b. And then multiply by a over 2b. Okay, so this is x is equal to, and here when we multiply, you see that b is actually in the numerator. That's the natural denominator of 1. So x is equal to, when they cancel, it just is equal to a over 2. And you see how that is the x value of the midpoint that we had. Okay, now just to show that it is that full midpoint, let's go ahead and substitute that x value into our graph mn. Okay, seeing that p is an x value of that graph. So if we substitute it into that, remember it's just going to say y equals and then this y value. Okay, so the corresponding y value is equal to, we're saying negative b over a, and in place of x, we're saying a over 2 plus b, and so y is equal to, here the a's would cancel, and you have negative b over 2 plus b. Okay, now they're actually in terms of the same thing, because this is negative b over 2. You could have written negative b over 2 as negative 1 over 2 b, and then plus b. So this is y equals, and b minus a half b is a half b, which is just b over 2. I'm just rewriting this b, which is already in the numerator. I'm just putting it over there. Okay, so that proves it. You see that the maximum here, right? The maximum area will happen at a over 2 and B over 2, which is the midpoint as well. Okay, which is the midpoint of MN. And so that proves that that maximum area is going to be the midpoint of MN. And that is our answer. And that is it for question 9.